Okay, so scroll back up to the top and just change our rule from 3n plus 1 to 5n plus 1. And let's reevaluate this. Okay, now we've got to be careful on here. So do puzzle sequence, like start at the beginning and let's see. Let's go to 1, puzzle sequence 1, just to make sure we've got it right. So we should see 1.
1, 6, yep, 3, 16, 8, 4. Yep, okay, so that works.
Actually, instead of the 6,000s, change those 6,000s to 100s. Because I don't want to see 6,000 out. Okay, yeah, reevaluate that. Okay, now, so this worked, you think? 1, 6, 3, 16, 8, 4, 2, 1?
Yeah, that followed the pattern.
Okay, let's do 2. All right, walk me through the pattern now.
Okay, 2 divides to 1. 1 times 5 is 5, plus 1 is 6. 6 divides by 2 to get to 3. 3 times 5, 15, plus 1 is 16, divided by 2 is 8, divided by 2 is 4, divided by 2 is 2.
Okay, so why does it stop there?
So we've seen a 2 before.
Okay, and then so why have I decided to stop anytime we see a 2? Or, sorry, anytime we see a number we've seen previously?
Because we know the sequence will repeat eventually. In this case, the 2, once you get to the 2, you're going to go to 1 again, and 6 again, 3 again, 16 again, and then back to 8 to 4 to 2.
Alright, so let's look at 3 now. Okay, we don't need to walk through it, but it's okay.
We've seen that 3 produces a repeating sequence.
Alright, oh actually, you know what? We don't even need to look at 4 then, do we? Because 4 is in that sequence. Let's go to 5.
Alright, so we get 5, 26. 5 times 5 is 25, plus 1, 26. Divides by 2 to get to 13. 65 is 13 times 5, plus 1 is 66. 33, 166. Divides by 2 to get to 83. 416. And then we go to 208, 104, 52, and then back to 26, which means this is a repeating sequence.
Okay, cool. 6 I think we saw in one of the prior ones. In fact, we saw it in 1, but let's look at it anyway.
And so 6 produces this repeating sequence.
Alright, so what's your prediction for 7 before we look at it?
I think we'll get a repeating sequence. We've seen it for all the numbers prior.
Okay.
Alright.
But notice how long that sequence is.
Yes.
It got cut off by the 100.
So we haven't seen a repeating number yet. Or because it didn't stop because of that.
Go to, so maybe make these, actually I forget where this repeats, but maybe make it 200. I mean, actually, in this project we're not going to be using the other one, but it's fine. It's fine. We're only using puzzle sequence.
Okay.
So, did you evaluate it? Okay, so now do puzzle sequence 7 again. Oh, you did. So it's 200. It's hard to tell if this is repeating, right? The numbers are so large.
It doesn't look like it. Oh, let's see. We get 2. The last term is 4 billion.
Yeah, so go back up to the top. Maybe make it 300 long, and I'll show you what we can do to, or 400. How about? So let's do a list plot puzzle sequence. Puzzle sequence 7, and then because the numbers are getting so big, let's do log of puzzle sequence 7. That'll make the numbers smaller and it'll make the graph a little bit easier to read.
Just log.
Log, yeah. All right, so let's see. Does this repeat?
Well, it looks like we've got, like we get down. We do see. No, we don't see any patterns. Not yet.
Yeah, in fact, we know it's not repeating actually because we're using this puzzle sequence that'll stop if it ever
Yeah, and we get to
And we're getting
400.
to 400, so try 1,000, maybe. Did you evaluate up here?
No.
This is going to take a while to run. Oh, well, there we go.
Still not repeating.
We got 1,000. So this is kind of a surprise to me, that such a simple change from 3n plus 1 to 5n plus 1 produces something that doesn't seem to repeat at all. Does that surprise you?
Yeah. I mean, if this was the original Collatz conjecture, maybe, like, does this ever repeat? I mean, you said it did repeat at some point, but...
I don't know, actually. This is something I learned about this morning. I thought the 3n plus 1 version of the Collatz conjecture was just sort of a random one, and they all kind of behave the same way.
Yep.
But when you change it to 5n plus 1, even starting at 7, you get sort of behavior that goes on forever. We got about a minute of recording time left. Try see what happens with 8.
Let's see if this... Oh, this produces a
So
repeating
it stops
sequence.
very quickly.
Yep.
Just just try a random number, whatever you want.
83. That also repeats.
Okay.
Maybe another multiple of 7, maybe 21.
Okay.
Yeah, this seems to produce quite a long sequence. Yep.
Oh, there we go. Okay. So good guess actually. Maybe multiples of 7 are the way to go. Try another one.
Try 14 and see if it holds 4. Yeah, looks like it does.
So okay, interesting. So multiples of 7 seem to be giving us a little bit of trouble. Let's see if it gets to the end. Wait, is it still running, or is that the plot?
It's done. It reached 1,000.
Okay. Well, we're out of batteries, so or recording time. I mean, so this is cool. Fine. We'll take a look at a slightly more complicated version of this tomorrow.